All right, everybody, welcome to our Lambda School Brown Bag today. It is September 19th, 2018. So today we have a very special presenter, Jana Beck. So last year at React Rally, I had the privilege of seeing Jana Beck speak live and was like, hey, at Lambda School, we have these really cool brown bags, and it'd be really fun if you came and presented something if you're ever interested. And we kind of lost touch. And a year later, we resurfaced, and she's kind of been helping us out with a couple of things. So I'm really excited to have Jana. She's a friend of the program, an amazing developer, an amazing speaker. And I'll let her introduce herself and her topic, and we'll just dive right in. So feel free to ask any questions and through Slack or through Zoom. And yeah, Jana, the floor is yours. So thanks for coming.
Great, thank you. So the topic, as you can see on this slide, I hope, is better living through components. This is going to be a pretty React-focused talk. I'm primarily a React developer, but I think a lot of it applies to other frameworks as well. It's going to be more there'll be some technical details, but also a little bit about sort of how you build things for people to help them build apps faster. I'll get into this a little bit more about the kind of team I'm working on. But so I used to be much more of a traditional software developer. I worked for a small not-for-profit startup called Tidepool. It was a very tiny team, so I did a lot of mostly front-end work, but a little bit of other work as well. But then I moved into this role at Stitch Fix, which, if you don't know what Stitch Fix is, we are a personal styling as a service company. So basically for clothing and accessories. So people sign up, fill out a style profile, information about your size, and then we send you a box of 5 items. You don't pay up front, you try everything on, and then only pay if you decide to keep some of them. And the whole business, the business is relatively mature at this point. A company went public last November, and it's very data science driven. And I work in the data science group on the data platform engineering team. So actually, I'll dive into this a little bit now. This slide deck isn't online yet because I haven't deployed it yet, but I can give Ryan a link later if you ever want to reference these slides. They will be up on my website at some point. So yeah, I work in the Stitch Fix algorithms department. That's what we call our data science department. This link, I do advise when I send this out later, takes you, I guess I can show you. I should be able to show you. Oh, is the link broken? The link's broken. Should be able to bring it up pretty fast. This is just a nice little animated infographic tour of how data science is woven into our business. I recommend it. It's fun. I wish I could claim credit for this, but this was actually made before I joined, though I do work with the people who made it. So I work on this data platform engineering team, and our job is basically to help data scientists do their jobs faster and better. And our data scientists at Stitch Fix are full stack data scientists, which is a little bit unusual. A lot of data science groups kind of organize things in a handoff fashion. So they, data scientists will sort of prototype models and things like that, and then hand them off to data engineers, and they'll have front-end folks building dashboards for the data scientists. I do write a lot of code in collaboration with data scientists, but we definitely work in a much more they're expected to own the work to a much greater extent. For simple apps and dashboards, they're basically expected to put them together themselves. And we have a lot of tools to help them do that, like tools to help them deploy them in a secure manner with a reverse proxy service. And then what I'm going to be talking about today is some libraries of React components. And so these are non-presentational components are the ones that I'm going to be talking about. This isn't like a UI library. This is using components as a unit of abstraction to do other kinds of things. So basically, all relating to data, since this is a data science department. So data fetching, data persistence, so like saving and deleting, and even a little bit of data computation. We'll get to that at the end. So basically, this is the outline for this talk. I'm going to spend a little bit more time talking about how our team is organized and what kind of infrastructure we have. And then we'll talk about these fetch components, save and delete components, and compute components. So this team that we have, this is kind of a rough, I've already explained this a little bit. So basically our data scientists are organized in verticals, aligning with different parts of the business. So we have, there's kind of three really big ones, which is our styling, operations, and merch. So styling works with, they work on the models that help populate what the stylists see in the styling app. So basically helping to match clients with clothing. And this is all pretty much real time based on what's in our warehouses. And like as soon as a stylist selects an item, then it is not available for other clients, right? We have to make sure that, that whatever the stylist picks is available. The operations is things like warehouse operations, logistics, all of that kind of stuff. Merchandise is, clothing. So that covers algorithmic sizing, trying to determine which brands run large and small based on the feedback data that we get from clients, and then better matching clients to sizes of clothing. And we also design clothes with data science. So we code up attributes of different styles, and we try to figure out what combinations of attributes. So there's a lot more of these for women's clothing than there is for men's. So these are things like what kind of sleeve it is, what kind of neckline it is, what kind of fabric, all sorts of, there's hundreds and hundreds of these features, and we figure out what the best combinations of those are, and then use that to create new styles. And that's very much a lot of Stitch Fix is what we call human in the loop data science. So, there are actual stylists picking out clothes for clients in collaboration with these algorithms that are sort of populating what they see in the app. And there are actual merchandising experts that help design clothes based with these algorithms that select features that are, or predict features that will perform the best. And so then our data platform team that I work on, there's about 25 of us now. There's only 3 of us who are front-end specialists. Most of the folks on data platform are sort of compute infrastructure folks. Also a big team that helps productionize the models that data scientists come up with. But basically, again, by building tools for the data scientists rather than having a handoff where the engineers are implementing something for the data scientists in production. So basically, long story short here is that this team is very technical, but they're not technical with front-end web development. So they're not just these lay people who don't know how to code, not at all. But the kind of stuff that they're coding in is Python, it's R, which is a statistics sort of programming language and piece of software at the same time. They use Apache Spark a lot. This is kind of just a small sampling of the most popular tools. And our stack is huge. It's got a ton of moving parts for different types of data, real-time data versus batch jobs, all sorts of things going on there. To simplify it a little bit, this is just the sort of web stack that we have. So if we have a data warehouse, and whenever data scientists need to surface data from that warehouse in a web app, the web stack basically involves these 4 parts. So Hive is a meta store that basically stores table schemas and database schemas. Presto is a SQL engine. So it runs, and it's the engine that we use for ad hoc, so on-demand SQL queries of our data warehouse. We use Spark for the production jobs, like batch jobs, but Presto is the ad hoc engine. It's also what people use in a desktop SQL client when they're just prototyping, or in a Python notebook, if you've ever seen those. Flask is a Python framework for building lightweight APIs. So the server that we have that like serves up these ad hoc queries that surface in web apps is written in Flask. And then we also have Redis sitting there as a caching layer, so that we're not, the Presto cluster tends to get a little grumpy. So we try to avoid hitting it too much. And this whole collection, the web stack of our data warehouse, we call Fogtown, is our sort of internal code name for it. So I'll probably say that a lot. And so it's a pretty simple, again, it's just this Flask app with a little bit of Redis for caching. It's all GET requests and basically a limited SQL interface via a query object that's in the headers that you stringify and stick in the headers of your request. So that brings us to the fetch components. Before I really dive into them, the inspiration for this is completely a talk by Ryan Florence that I recommend watching, just absolutely recommend watching. I've probably seen it 4 or 5 times at this point. Not only is the content great, but Ryan is amazing at live coding, and you will see that in this talk. So the title of this talk was this component, fake React component rethinker. And basically it was Ryan wanting to encourage people to use components. This was sort of at the height of, this was 2 years ago that he gave this talk, I think. And it was kind of at the height of the Redux craze, I feel like. And so everyone was using Redux even in very simple apps. And Ryan kind of asked everyone to take a step back and think about that. And so just a few quotes from the talk that I think are great. Basically, the thesis statement is we didn't give components a fair shake yet. And so if you've got a problem, try just making it a component and see if it works. And then again, like a really big theme here is using the React lifecycle or any framework's lifecycle to make something declarative that's not like fetching data. And other things as well. He actually, one of his examples in the talk that's really fun is using the web audio API. So his example looks basically like this. This is one of these nice little live code playgrounds. So you're using the lifecycle in this component did mount to fetch some data. And then if we look down at what's actually being rendered here, this is the so-called render props pattern. So providing a function as the children inside this fetch component, and then when that function gets called, which is in the render method of fetch, doing something with it, so deciding how to render it. This is becoming more and more popular, this pattern. So that's how he kind of put together this first example of this in this talk of his. So I just we'll get into some of these details a little bit more. So I want to start with what we initially did at Stitch Fix to create the fetch component. So we call this one Fogtown Fetch because it fetches data from this data warehouse. So, just initializing some state in this component. There's no data yet. There's no errors yet. We're not loading data yet. And then in the component did mount, just the same as in Ryan Florence's example, we fire off the request. This is, if you look at like line 18 here, I feel like I don't see people using this super often, that you set state and then there's a second argument, which is a callback. So if you want to make sure that you don't do your next thing until your state has been set, so until you've set loading and maybe rendered a loading indicator, then you do it like this. You use this callback function. So we just fetch, again, this is just our little, I've actually put up a little fakey server for this that kind of does the same thing with this query as a header. And then we handle the success in a pretty typical way, just set the data in state when it comes back, and now we flip loading back to false, or you handle the error if that's what happens. But here's where what we initially did is a little different from Ryan's example. I really wanted this to be really easy for data scientists who don't know React, and the render props pattern is a little bit weird. And it requires more effort because the consumer of the component, this fetch component, has to handle the error state and the loading state themselves, which is nice for flexibility, and we'll get to that, but it's not great for data scientists who really just want to put something together super quickly. So instead, I did something where I render a default error message, I render a default loading message based on the state, and then I clone the children. So they provide, instead of providing a function as children, they provide just a component that will then get this state injected into it via React's clone element. So here's a live, oh, and look at I spent a bunch of time making sure that error would surface. Uh-oh, though, because I think I did. Uh-oh.
Always happens.
I know, right? I think that's not actually the right error message at this point. I think it's just, there we go. Woohoo! All right, saved it. I must have changed that example and not realized it, that I saved it. So this is a live version of this example. So as you can see, I can change. The only thing I've really implemented in this little fake server is the limit part of the fake SQL query. So I can choose how many rows. This is actually, I did copy this table out of our data warehouse because it is somebody put up a poster one Friday querying everybody about their favorite flavors of La Croix sparkling water. And I ended up counting up all the votes at the end of the day and making a little table and putting it in our data warehouse. And I use it for examples all the time internally because it's fun, right? So, and it's like simple. And I can share it with you because it's not company data particularly. So yeah, so this is basically the pattern, just looking at it live. We didn't see this in the last slide, so we can look a little bit about what we're actually rendering here. Is, you can see when I highlight, right?
Yeah, it looks good.
Okay. So what's actually being rendered here is, one of these fetch, we're specifying the table. So it's this LaCroix survey. And then in this case, all that is in the children is just this data display component. So this is the component that the data scientists would write themselves with no props. And so the data just gets injected into it here because we're cloning it. This second argument here gets like added to this is kind of like an object.assign. You take the props from the children and add the state. So that was the initial API. Now that only works for this one particular resource, the data warehouse, which is just doing GET requests. So then we can try to make this more generic, right? Basically just by passing in the URL as a prop, passing in a body potentially, passing in the request method, and then this is all just the same. The render method basically stays the same. So if we look at that live, this is one of these JSON placeholder service that you can use whenever you're prototyping stuff. And so this is just another fetch example. That one's actually not that exciting. It's basically the same as what we just saw. Here is one where what we provide on the fetch component, we provide a body that is going to get posted. The method is post, and then the URL there for the JSON placeholder. So now we have something that's pretty generic. You can use it for almost anything. Now, I said before that I didn't want initially to do the render props pattern because I felt like it wouldn't be very approachable for data scientists. And I think that that's generally been pretty true, but data scientists aren't the only folks that use these components. Me and the two other people on the same team that I'm on, we use them a lot as well when we're writing code for apps that we own or apps that we sort of co-own with data scientists. And it does get annoying to have to kind of abstract out a component all the time rather than just, you basically end up having extra files if you have to write a new component that is getting the data injected into it rather than handling it directly with render props. So this was actually pretty recent that I just added a little bit of logic to that render method that just says, just type checks the children, and if it's a function, then we just use the render props pattern of calling that function with state instead of rendering the error message or the loading message. So now you are responsible for doing that yourself, but this is like a nice little escape hatch for more advanced developers, basically. Yeah, so this is just an example of using the render props. So you can, you know, when I have this, oh, I lost my cursor, there it is. I can, so here I just am returning the length of the data that we're getting back. I could, you know, display, wow. I think there's like keyboard lag that's making it look like I'm typing things out of order. I can stringify the first result. You know, I can do whatever I want just right here in this function that I'm providing as the children. So that's basically that pattern. So that's the fetch components. Now, moving on to save and delete. So we have a generic service for this at Stitch Fix. It's called Red Velvet because the engineer who owns it is really likes to bake, and he names all of his services after baked goods. So here we have a lot more options. We also have GET requests, obviously, to retrieve things from this generic storage service. So this is generic storage for anything that's doesn't belong in the data warehouse, right? It's not actual sort of company data. So it might be things like user preferences in apps. Like we have one of the components I created that I'm not actually going to show you, but that is a nice drop-in, is a component that is basically renders a little star so that you can favorite things in apps. So it's very easy to drop in just an ability to let people favorite things. This generic storage API has namespaces for both things that are public and things that are specific to each user based on their login email, because we have the way we deploy all of our web apps, every app has access to the currently logged in user's email, logged in via our single sign-on, right? So for the GET request, we didn't actually look at component did update. We were just looking at doing the GET in component did mount. You can, in our actual components that we have created and published in these internal libraries, we also do hook into component did update in case the props change, right? And you want to refetch the data. A little reminder here, depending on how much you know about what's going on in React these days, but you shouldn't be using component will receive props for that anymore, for those updates, because that lifecycle method is being deprecated. So we were using that and had to change recently. But it's not immediately clear what, if any, lifecycle methods are appropriate for these post requests to persist data, either posting it or deleting it. And because those are dependent on user action, right? So I'm just going to say, instead of a lifecycle method, let's have an instance method on our component. And that instance method is a handler for a button that we render. So I lied earlier, basically. This is better living through mostly non-presentational component. We're actually going to render a little bit of stuff. So this is the basic save component API. Again, very similar start, initializing some state, error in flight, like the equivalent to loading state. And then very similar, just fire off the request. But this time we're inside a handle click instance method. And the data that you're posting comes in via the props. We already kind of saw this with the generic fetch. Handle the success as per usual, handle any errors as per usual. Here the render method is not render props, and it's not anything with cloning elements, it's a button. So then this form class that we're going to look at, this is the kind of thing that the consuming app writer would sort of, perhaps a data scientist would write. So they write this form method, they handle the input state, and then that input state, which is hooked onto the on change for an input, is what you're going to be posting. So now this is the fun one. So we can actually save something here. So I click save. We're going to talk about why we didn't see anything happen, but I will show you that in this little mini server, that foobar, and you probably can't quite see, can you see this other tab? Yeah. But you probably can't quite see that it's there, but it's there. The foobar that I just typed.
It was visible.
Oh, it was visible. Great.
Yeah,
all right. So, but there was no feedback when I clicked that save, right? We had to go to Mongo Lab and verify that it was there. And that's obviously not a great experience. So there's a few things that we need to do to really make this save component better. One is just simply handling disabled state. So this you could pass into the save component as a prop. And so you might, and then pass it through to the button, right? In the save component handles that. So if we look at, so now we have disabled state, and basically the way I've done this is that which I'll show you here. So the form, this is the class that the consuming application is owning, is just determining this based on whether there's any input at all. So right now it's just disabled if you haven't typed anything, but as soon as you type something, then the button goes dark red, and we know that we can click on it. I guess before we had anything there, the cursor is also the whole not allowed cursor. Of course, that's coded in your CSS, but you can provide that along with the component in the library as well. So that's a little bit of feedback. We also want to know when our save click was registered, right? Handling that in-flight state, knowing that the request is in flight. So here, this can be done just by changing what we actually render as the button text, for example. So that's all inside the save component. So that's not part of the responsibility of the consuming application at all. So this will be probably very, very fast, so it'll be hard to see, but it's going to change to saving, right, very quickly. I do actually have in our actual APIs of our internal libraries, there's an option to put a timer on that if you really want the experience of not having UI flash, so the very polished experience of a minimum of 250 milliseconds of that saving text. So that's, I put that in for a little bit of polish, basically. So now there's one more thing that is possible here that I actually think is pretty exciting. So kind of melding together the save button and making sure that any data that you display to the user is fresh. So here we actually have a display of our saved text. So if I open this up, so we are using both things here. That we have this on component did mount in the form component. We are fetching the current data, and then we provide a callback to the save button. And whenever you save data, we look for that callback. If you've provided it, it's optional, and then fire it off. So then we refetch the data so that we ensure it's always fresh. So if we look at this, we can say, save something else, and now it refetched the data, so it's always fresh what you're displaying to the user. That callback can also be, I think I have more on this. Yeah, ensuring fresh data. So yeah, so this is part of our success handling, is firing off that callback, and that's provided on the saved. And so that callback could also be a Redux action creator. So there are some apps that, so by and large, in the process of creating these internal React libraries, I've encouraged data scientists to not use Redux. When I joined the company like a little over a year ago, when I started looking around at the simple apps the data scientists were building themselves, I just saw that there wasn't, a lot of them had been encouraged to use Redux, but all the data that they were fetching was only being used in one place. So it was really kind of overkill in terms of having this big global data store that isn't really needed globally. But of course, there are some apps that get a little bit more complex where you need the same data displayed in multiple places on the same page. And so then we do, and I do this a lot with some of the apps I own, have kind of a hybrid architecture of using Redux basically as sparingly as possible in combination with these components. So and so it's just a little bit of a refactor when you suddenly realize that you need the data in more than one place in your app, then you pull it out into Redux and get rid of the fetch component or the save component or whatever. Well, the save component you can still kind of keep. I think that Redux tends to be a little bit more useful just for the data fetching and global store. And then I haven't talked about delete components yet, but I'm just going to leave that as an exercise. They're basically exactly the same as the save components. And in fact, in our code base, there's actually just a generic persist component that some people use directly occasionally. I think there's some service where you actually have to delete things via a post request. And so that's why I had to make this part of the public API. But basically the save and the delete that we actually published are just a wrapper around a generic persist component. All right, so we're on to the final section, which is, I'm not going to make you look at too much more code. It's been a lot of code so far. So compute components. Your first question might be computing in the browser, and that's a very valid question. It's definitely not what we normally do at Stitch Fix or anywhere else, but there is one use case that's cropped up recently, which this is too small to see. So this is TSNE for TensorFlow.js. It's a recently published project. And as it says here, it's an improved TSNE implementation that runs in the browser. And you might be asking, what's TSNE? So it's something called T-distributed stochastic neighbor embedding, which probably didn't help. Another way to say it is that it's a technique for dimensionality reduction, which also may not help. But basically what that means is taking data that has many, many dimensions, so many attributes, and finding a way to map those into either a two-dimensional space or a three-dimensional space. So the example that they actually used when they talked about publishing this TSNE implementation for TensorFlow.js is this huge data set. I think TensorFlow is a Google project, so I think this might be a Google data set. I could be wrong about that. It's some 60,000 handwritten digits. So you should be able to see them here, 0 through 9. And so the reason why this is a high dimensional data set is what they actually did is they put a grid on top of each handwritten digit, and then like a grid of the same number of dimensions. And then they code for each square in that grid. There's probably, I'd have to look to know how many, but there's probably at least 100 or so squares. It's a 0 or 1 about whether that pixel is filled in, right? And so that's the data that you're trying to use to group just these images of colored in pixels or not into the digits 0 through 9. And so this is the GIF that they published that shows t-SNE operating to cluster that high dimensional data into a 2-dimensional space here. And as you can see, since they color coded them based on the human assessment of what the actual number is, it works pretty well, right? You're getting mostly the same colors grouping together. So that's the goal with something like t-SNE. And so the reason you would want to do this in the browser is for, you know, a data set that updates frequently, basically. So you want to be able to do it live for users. So why would you want to do this as a component? Again, just like any of these things I've been talking about, making it declarative using the lifecycle method. So just making it a little bit more understandable in that way. But then really the motivation for me on this project has been to cache the computed result, because this t-SNE in the browser does take quite a long time on a real data set that's large. And so it's not a fun development experience if you're doing it as a component, and then every time that you're like code hot reloads, you have to wait like 2 minutes again to be able to iterate on the display of the data. So for faster development is one reason, but then that also just totally plays into for better user experience for the users when they're navigating between pages. So if they go view a t-SNE display for some data that they're looking at, and then they go to something else, and then they want to come back, we don't want to recompute. t-SNE is actually non-deterministic, so you will also get a different result every time. And sometimes they're better than others, and tuning it is a big problem. But it still would be nice to have a caching option, basically. So this isn't really code. This is more just kind of a sketch of what this component might look like. Huge compute method, but this is pretty similar to all the like fetch things that we just saw. Just some fake data here in line 42 of like just calling t-SNE on the data and assuming that it returns a promise that gives you the coordinates. Oops. And but the new part here is that we might imagine in this kind of component having a Boolean indicating whether you're going to cache the result and then putting it in local storage on success. And so that also means that in component did mount, we look to see if we're trying to cache things. We also might have a recompute, like a forced recompute prop. So we look at both of those things, and if we are caching and we're not recomputing, then we pull the coordinates out of local storage instead of computing them. And then again, you might want to do a similar thing on component did update about forcing this recompute. And just using a render props method or something like that here, pretty familiar at this point. So that's basically it. I would say my conclusion or takeaways I hope you have here is that components can be a really good unit of abstraction, even for things that are not presentational. They're approachable. You know, one thing we advise data scientists to like take the official ReactJS tutorial. I don't know if you've looked at that. And it doesn't mention the render props pattern. That's like often the advanced sidebar of the React like documentation page. So this kind of API for data scientists, is good when that's all they've done. All they've seen is components with props and state. The components are also, they're really nicely encapsulated, as opposed to Redux where you might have like 4 files open to implement a feature. With this, hopefully you've got 1 or 2. And then the final one is that providing a component API like this makes documentation really easy with Storybook or Style Guidist, or I think there might even be a couple other tools for making sort of style guide types of documentation that are based around the abstraction unit of the component. So that's it. Thanks. And questions are great if you have them.
Awesome. Yeah, a couple have came through. I'm going to ask you a follow-up question to what you just barely said about learning some of the more advanced features of the React API. We teach pretty fundamental stuff, but we go into enough depth to uncover some patterns like higher order components. We do teach a week on Redux here at Lambda School. So some of these students are pretty darn familiar with fundamentals and beyond, but what are some of your other recommended resources besides maybe the React documentation that you mentioned for learning more about the render prop pattern?
Yeah, I mean, I think learning by doing is always best. And so I think the first library that really popularized render props was React Motion. So if you ever want to play around with animation, like you will have to use render props with React Motion. I think it's actually, it hasn't been super maintained, and I think there might be better options out there now. But they might also use the render props pattern, probably. So
cool.
Yeah, I would say finding libraries that like use those patterns is one of the best ways.
Yeah, and just so students know, here we do teach React Router version 4, and there are patterns that expose the render prop pattern on the route component. So when you get there, if you haven't yet, or if you already have gone back through there, you can go back through, and instead of saying, path equals this, mount this component, you can say render instead of component equals this. So you can look into that and kind of see the pattern and how it's used there. It's really, really useful. Cool. So yeah, a couple of cool other questions that some students asked. Do your AI programmers have access to CUDA or CUDNN workstations, or are they remotely?
I don't know what those kind of workstations are, so I think the answer is probably no.
Okay. Yeah, it's a good question.
Our stack is, we are entirely on AWS. We use a bunch of different instance types and cluster types, but it's mostly Amazon ECS. So they're sort of Kubernetes, not quite Kubernetes.
Awesome.
The Elastic Container Service. Yeah.
Cool. All right. So you may have to look more into that, Mark. Good question, though. Jeff gives you a little feedback, and he also asked a couple questions. He says, beautifully presented, so +1. One tip he's giving is you might want to use F11 full screen on browser if you take this to like a meetup or something. Mm-hmm. But he said your code was super clear. Not sure how to plan around possible exec call. I don't doubt that you're capable of using control fields to make components without it, though. So a little feedback there. And then he asked this question: how did you manage the live reload? I guess I'm assuming, Jeff, if you have more follow-up on that, I'm assuming that's in your slides. Is that what you're talking about? Like, so you had your code, your text browser, and then your little code browser. So he's wondering how you kind of put that all together, I think.
Yeah, it's totally not my code. These things?
Yes.
Yeah, this is called the component playground. So this whole thing is done with a React-based slide deck or slide program called Spectacle. It's a project of Formidable Labs, which is a React agency, and development agency. And so this is called the component playground. This one is not Formidable's code. It is James Kyle's code. It's like an add-on package
cool.
Called Spectacle Code Slide.
Awesome. Yeah, Formidable. If anyone wants a fun Twitter handle to follow, look at Ken Wheeler from Formidable. So,
yeah, I mean, I think Ken Wheeler wrote most of this package, Spectacle.
Cool. Yeah, they're an awesome agency. So they do a lot of cool presentations and things like that. And they just put a lot of really cool stuff together. For the industry, a lot of fun packages. Cool. Lucas asked about possibly getting some code snippets that we can play around with.
Yeah, so this, even though I haven't deployed these slides yet, the repo is already public. So it should be this. My GitHub is J.E. Beck. So it's here. I haven't, so the code examples are in these assets, and unfortunately they're not like, I can't remember why you have to do this, or maybe I'm just boilerplate copying the spectacle examples. Like, I'm not sure why they always name them with non-JavaScript extensions, but oh, I think it's because you're using a different Webpack loader for them. So probably Webpack would get confused if you're trying to use a different loader for a JavaScript file.
Gotcha.
So this is in order to load them into those component playgrounds or into the code slides. So they're not like in a super great, you know, it's annoying that they don't have syntax highlighting and stuff like that when you look at them like this, but they are there. I will probably try to also put them together probably in a different repo of like more runnable examples. There's another repo already. It'll probably be in this other one. This is where the little tiny server is right now. And I'll probably put the runnable examples here. I'll probably just use create React app to like put something together that you can run.
Cool.
Yeah, I still have to think that through. I got to figure out if I'm really going to keep this. I don't know if I need to put any protections on the little like Mongo Lab instance that I stood up. If I put it out there in the public for everyone to run against. But yeah, hopefully not. I guess I can always just take it down if people start abusing it.
Right. Cool. Awesome. Yeah, that'll be fun. Create React App students could easily just grab it and fire it up. So they're pretty savvy with that package already, as well as Code Sandbox. There's a lot of good stuff that Code Sandbox.
Oh yeah, that's a good idea. Yeah, or I could make them. Yeah, I could put them all up there. That might be easier.
Cool.
We'll see.
All right. Eli mentioned that React Apollo uses render props for their mutation and query components. It would be a good chance to learn React render props and GraphQL. Awesome. Thanks, Eli. It's good to see you again. And then, yeah, it looks like Mark responded to that AWS question about the CUDA, that he said that they do have CUDA options. So cool. That was all the questions and that came through. Does anyone else have anything else for Jana? Looks like a couple people. I did miss Ashton's question, but I already answered that asynchronous, like through text in the Zoom channel. There's a couple of ways. Ashton, while you were giving the example about on click, so you're clicking to save and firing off the API call, he was asking about ways you can do that with like the enter keyword on like a submit, and I think I gave a couple of examples there. You could do that. So you could look into those two different approaches that I mentioned for Ash there. So thanks, Lucas. Anybody else? It's so fun. I loved that you got into TensorFlow a little bit. Students who are looking into potentially expanding their JavaScript knowledge and looking into the realm of data science. Have you played around with TensorFlow at all, Jana?
Yeah, so I wonder, I probably can't find it super quickly. I am super excited, and later today I'm going to test it in Chrome apparently. So I have dug into the TensorFlow code base to do one thing, which is, so we actually have Stitch Fix. They're public. You could go look at them, github.com/stitchfix. We have 2 forks of TensorFlow core and the tsne library. Cool. Because I was working with the tsne to put something together for an application that I'm co-developing with a data scientist. And it was so painful. I mean, the computation takes so long that the tsne is implemented with WebGL. And so the TensorFlow library as a whole has a whole bunch of, they call them backends in the code. And one of them is WebGL. And some of the other functionalities in TensorFlow can use, like you can tell it to use a particular backend, but I think because of the way the tsne is implemented, it can only use the WebGL backend. And so that was really frustrating. And I've worked with web workers a lot, actually, at my last company. And so I thought I would love to put this in a web worker so that it doesn't. So if you don't know, a web worker is a way of running JavaScript basically in a separate thread in your browser. So then your UI doesn't freeze when you're doing something really computationally heavy.
Right.
So I started working on that with the critical lack of research of not realizing that WebGL does not exist in web workers yet. Then I found out that it did in Firefox in Firefox Developer Edition with a flag.
Okay.
Using something new called off-screen canvas, which is basically WebGL in a web worker.
Okay, cool.
So I hacked through the TensorFlow code base to add support for the off-screen canvas as an additional WebGL backend, and I got it working. I was talking to my manager about it yesterday, and it turns out, so I don't know if you all noticed the new ugly tabs in Chrome, but Chrome 69 just shipped. And it apparently off-screen canvas is now part of Chrome 69. So I'm going to test it in Chrome
There
today.
you go.
And see
You got
if
your
it works.
platform. That's so fun.
So we're hoping to do a pull request eventually from Stitch Fix against TensorFlow to get that off-screen canvas. Unless they've already added it, that code base is moving incredibly quickly.
Yeah, they're putting a lot of energy into that.
Yeah, so it's possible they've already added it. Since the last time I looked, that would be great. But for now, we're using our fork.
Cool. Awesome. All right. And then Cruz just had one more thing to say. He said, just a comment. I love seeing these patterns. Wish I'd seen some of them before Lambda Labs, which is the capstone phase of the students building their own project from scratch. It's kind of the culmination of the whole experience. So yeah, definitely look forward to all, future talks about these types of patterns, these things that you can see. And yeah, Jana, thank you so much for your time. This was actually really, really fun, really informative. So yeah, if you don't mind, I could drop your social media links, your GitHub links into our Slack, and students can go and follow you and look for future cool stuff that you're doing with all the data science team at Stitch Fix. That's so cool. So
yeah, I will if you already have those, feel free to do that. And then I will follow up with you with an email later when I deployed the slides and maybe have more examples up somewhere.
Awesome. Okay, well, we look forward to awesome things from Jana in the future. I'll drop her social media stuff in Slack. And all right, thanks, gang. Thank you so much, Jana. We'll talk to you all soon.
Thank you.